Hello everyone. In this video lecture, we are going to see the relationship between true stress and engineering stress and true strain and engineering strain. So first, let's know about the true stress and engineering stress definition. Engineering stress and true stress. Say, uh, let me take an example of a rectangular bar. You apply a force P. Originally, it had some cross-sectional area of A naught. This was the original area, but the final result would look something like this. Not exactly final, but the intermediate or say whatever, but the area shall not remain the same, it will change. So at a particular instant or say finally, it will be say A at any instant or say at the final area would be A. So engineering stress and true stress. Engineering stress will take only the effect of original area. So let me write it again. Say engineering stress sigma engineering is equal to P upon A naught, whereas sigma true stress would be P upon A. So now how would we represent true stress in form of engineering stress? So say sigma true is equal to P upon A into A naught by A naught is equal to P upon A naught into A naught by A. So this will be sigma into A naught by A, sigma engineering. So sigma true is this. So now we assume that there is no change in volume. This is based on assumption. There might be certain change in volume. You never know the effect of Poisson ratio or any other thing, but we have assumed it like this. So A naught into L naught will be equal to A into L based on our assumption. So A naught upon A would be equal to L upon L naught. So we can rewrite sigma true is equal to sigma engineering into L upon L naught. So sigma engineering, the final length would be L plus delta L upon L naught. So this was L naught. So sigma engineering 1 plus del L by L naught is equal to sigma true. So sigma true is equal to sigma engineering 1 plus epsilon naught. Epsilon is the strain value. So this is the first result that we have got. Now on the same lines we will be deriving the result for true strain and engineering strain. So this much we have written. Now I'll add one page here, add a page. Now after that we will see true strain and engineering strain. True strain will be something like sigma. First let me write about engineering strain. It would be equal to delta L upon L naught, whereas to derive the value of a true strain we have to take the effect of elemental strain and integrate it. So this will not be like this will be something like del e, no, del, small part, that is de, would be equal to, and say this say del e is equal to d l upon l. So this is the l is the value of length at any instant, and dl will be the small change at that particular length. So on integrating this from l0 to l, so from say 0 to epsilon true, so et would be ln l upon l naught. So this will be ln 1 plus l plus delta l upon l naught. This will be equal to ln 1 plus delta l by l naught, which can also be rewritten as l1 plus epsilon non engineering is equal to epsilon true. So this is the representation of true strain in form of engineering strain.